Hello my dear students, welcome to one more amazing session from Infinity Learn NEET YouTube channel. How are you all? This is Suresh, Faculty of Chemistry. So can you all able to hear me? Can you see me? Yes, give me confirmation so that we can start the class. आज हम चर्चा करने वाले हैं Alkene Power Booster Revision. So in one shot total Alkene का revision एक ही वक्त में करना चाहता हूँ. So please like this session, share with your friends, subscribe to Infinity Learn NEET YouTube channel. Here in this session, so take a pen and paper and write all noteworthy reactions, and some tricks and tips will be ahead for you, right? So let's start alkanes power revision. So the importance of alkane comes with various chapters in the overall organic chemistry. That's why I always recommend you guys connect with alkanes. So this alkene gives a lot of impact in this reaction mechanisms. So let's see the preparation and properties and the reaction hierarchy of these alkenes. Bachcho, before going for the alkene, I just want to give you a slight promotional slide over here. So whenever you are preparing for any examination, it is important to know where exactly you stand, how you are preparing. You are doing hard work. Really, I appreciate it. And the hard work should give a direction. So for the direction, you have a proper assessment platform. Hello, who is this? Radhe Radhe Betu. Okay. Arush, doubt? अरे शुरुआत में डाउट पूछ रहा है पक्का definitely we are going to accept your doubts. Okay, just present your doubt, whatever the doubts you have on the live chart, you can do it, and I'm going to explain any kind of doubt in the chemistry. So talking about the test series, here it is a proper assessment platform for how you are preparing for your NEET examination. It is prepared by eminent faculties from the NEET team in the assessment platform here, and it is according to the latest NTA examination pattern, and this is developed in such a way that it gives a real-time simulation for your real-time NEET examination. So while it in the description box, the link is available, you click it and you just go through it. 11th standard, 12th standard, repeater go, alag package rakha hua. And before you just go for the purchase, you apply YouTube 30 off, so that automatically 30% discount bhi milega. Okay, so GLP lens, DLP lena hai. Okay, big fan. That's good, great. Let us start the alkene, preparation of alkene. So how to prepare alkene? Alkene is CnH2n and it has a double bond. How to introduce a double bond? You can break the triple bond instead of that. So I want to go for Sabatier-Sanderson reaction, hydrogenation. What happened? Alkyne, when hydrogen is added in the presence of palladium, you are going to get direct alkane. Alkene nahi ban rahe. This is what is called exhaustive hydrogenation beta. Okay, you are asking some doubt. Arush, please ask your doubt so that not only you, all the students in the class is going to get a benefit of this. So chat box mein lage raho. Those who are online, please like this session, share with your friends, subscribe to Infinity Learn YouTube channel, so that ताकि आपको मिलेगा आगे classes रखना है क्या है. And you see the next series is launching in the next week. So we start with electronic effects that gives a lot of impact to the overall organic chemistry. Dear students, let's see if it is a hydrogenation, exhaustive hydrogenation. You are going to see partial reduction. Partial reduction means the double triple bond is there, is not completely hydrogenated. It is partially hydrogenated. That is called partial reduction by Lindlar's catalyst. You are going to add PdCsCO3 or PD. If not, you can use BaSO4 because they act as a catalytic poison where quinoline is taken. This is your quinoline, जो benzene का जैसे structure देख रहे हैं ना, this is what is called quinoline, and this quinoline or isoquinoline is used as solvent for this, and you can see you're going to see a syn addition and a cis product is formed. While you can see the partial reduction with sodium in ammonia, you're going to say this is also a partial reduction. So you are going to get an anti-product. It is a trans alkene is the product in this reaction. Bachcho, what is a syn? When a addition takes place in one side, it is called as a syn, and whenever double bond is there, you are going to get anti. so opposite side or on the same side. Like that, you can just learn the organic chemistry in such a simplified version so that you can do the best. So stay tuned in this session, throughout this session. I don't want to take a lengthy session. In this lengthy session, all the reactions that I'm going to give you in a simplified version, and one round of booster revision can happen in this session. But sir, JEE and NEET, which is better? So both are better, both are conducted by anti-examination, सिर्फ नाम बदलता है बेटा. Now talking about exhaustive hydrogenation, exhaustive, where mechanism you can see, you don't have to need to learn the mechanism, but it is given to better understanding here, beta. And this is a NEET channel. So palladium is going to add as a surface catalyzed reaction so that hydrogen is being added on the one side of the bond, so that it is said to be syn addition. So in this exhaustive hydrogenation, the hydrogens are being added on the both sides, so alkyne is directly going to be converted into alkane. Reaction यही condition में रुकता ही नहीं. You want to stop the reaction there, you have to use a catalytic poison. If you use a CaCO3 or a BaSO4, this acts as a catalytic poison. This catalytic poison makes this reaction to stop at the level of alkene. So when the palladium is reacted, just like in the previous reaction, bacho, you are going to get a reaction that stops at the alkene, so that hydrogen is being added in one side of the double bond, so that it is called as a syn addition. And the product that you are going to get, a cis alkene is a product. This is a stereo-specific reaction, bacho. And also, you can say, this is the way you study in this preparation, bacho. But here you can see, in the examination, जैसे structure देखा आपको डर लगता. So, by looking at this, you don't have to see total bird, but you can see only bird's eye. So, you can kick it here, so that hydrogen is being added at the same side, ताकि आपको cis alkene मिलेगा. Okay, why are terminal alkanes significantly more acidic than alkene? That is a very good important question. Okay, who is that? Surya Pratap. Terminal alkene जो है ना, are C triple bond C minus and H plus, and this is stabilized because of the sp hybridized electronegativity is increased. As electronegativity increased, negative charge is getting stabilized, so that its conjugate base is going to be more stable, so the terminal alkynes are going to be more stable. Are you getting or not? Clear? Betu, okay, Surya Pratap. So you change in the name, so I can say you Betu. So my dear student Betu, she is the student attending my classes on the regular basis. Okay, how the preparation is going on, Betu? So moving ahead, and the next reaction that I want to show you, controlled hydrogenation. And in the controlled hydrogenation, you can use the sodium mechanism. You see here, beta, mechanism you see, alkyne when it is reacted with sodium or lithium. So उसमें zero क्यों लिखा? इसका जो oxidation state है, you are going to get a transalkane. So what exactly happened in the first? Sodium or lithium are being alkali metals is going to lose electron so easily, so that the free electron is formed. That free electron is going to attack on this pi bond, so that a free radical is generated. You see, this is a kind of weird situation where radical as well as anion being generated. So this anion is going to take the hydrogen that is given by the liquid pure ammonia, so that it is protonated. So once protonation happen here, this odd electron is going to take one more electron that is available in the solution itself to become anion. Again, one more hydrogen is being added in the opposite side. At the end of this scenario, hydrogens are being added in the opposite side. So it is what is called as a anti-addition. The product you are going to get a trans product. Are you getting or not? No, घर से class ले रहे. So it is from the office itself. Today being a Saturday, office is a holiday, so that all cupboards are being locked. So I could not have a chance to change my t-shirt, so I am wearing my personal t-shirt. I am taking class. कैसा देख रहे हैं मेरे t-shirt? एक thumbs up और fire emoji. So हर बार हम t-shirt लेके आ रहा है ना, अभी हुडी से ले रहा हूँ. Going preparation of full wing. God bless you. Now moving ahead, बच्चों. That's good. And my dear students, I am expecting you to just give more likes in this class, more comments in this class, so that we can have very good discussion, right? That's good. Fine. Now moving ahead, let us say this is the question when it is given as an alkyne, this alkyne sodium in liquid ammonia. You can use NaHSO3 also as a source of a proton over here, so that you are going to get a trans alkene. नहीं, today we have Arya Anuj, आज क्लास है, आप लाइक मार के पहले आना पड़ता है, लाइक मारो पहले. Those students who are online, please like the session, please subscribe to this channel. So we will be having a very good, awesome series from the next week onwards. Come on. So now we can see this is an alkene. When it is treated with the sodium and liquid ammonia, is a trans alkene. You got it? When you add here, when you as a Lindlar's catalyst, you are going to get, Lindlar's catalyst means cis alkene. So here it is a bond का हिसाब से यहाँ पर cis होगा और यहाँ पर भी और एक cis होगा, right? So like that questions will be there. Understand? Any doubt? Okay, moving ahead, you can see if this is the case, H2PD. So whenever H2PD is used, it is going to be exa-2 hydrogenation, so that this will react, this will also react, so the total alkane is formed. Okay, sir, आज एक है क्लास नहीं है, आज क्लासेस पूरा भरा हो बेटा, रात 10 बजे तक. Okay, so here I am being a teacher, I always engage myself to drive the students' academic program, so that continuous classes will be there, and I am happy to interact with such an awesome students like you. Come on here. Whenever H2 in Lindlar's catalyst is there, so ये डबल बॉन्ड नहीं रिएक्ट होगा, सिर्फ ट्रिपल बॉन्ड रिएक्ट होगा, ताकि सिर्फ alkene is the product. You see, this is the way you need to understand the reactions. This is the way you need to understand the reaction. Okay, happy? That's good. So moving ahead, preparation of alkene, we already seen this is going to be H2PD, quinoline BSO4, sodium liquid ammonia. You are going to get a cis alkenes in addition and a trans alkene anti-addition. So short reactions बना के देखा आपको, right? Any doubt? Now और एक है और preparation of alkene में dehydrohalogenation. What is the meaning of dehydrohalogenation? Deforestation क्या होगा? Cut the tree. Dehydrogenation क्या होगा? Cut the halogen. Dehalogenation क्या होगा? Cut the halogen. Dehydrohalogenation क्या होगा? Cut the halogen as well as hydrogen. ठीक है बेटा? So that in the dehydrohalogenation you are going to say alkyl halide, when it is treated with alcoholic potassium hydroxide, okay, you can also use ethyl sodium ethoxide and ethanol भी इस्तेमाल कर सकता, so that you are going to use elimination reaction. So hydrogen and halogen is eliminated. This is what is called dehydrohalogenation. उसमें आपका product मिलेगा more substituted product, that is called Sedgwick rule, and less substituted product, that is going to be Hoffman rule. So which is a Sedgwick product, which is Hoffman product? It is always is going to be the major product. तब Hoffman products कब होगा? Hoffman product is not generally formed. Hoffman product आता है NEET में, ऐसे questions हैं. So there are two conditions when leaving group is a poor leaving group, right? When our base is bulky. बस this is a simple trick you can use. Hoffman rule कब इस्तेमाल करना पड़ता? देखो tertiary butoxide is a bulky base, potassium tertiary butoxide. So stability of this alkene, you just follow this. So I want to use NEET में ऐसे trap आपको देखेगा. I will tell you if this is the case, बच्चों, if this is the case, what it has to be, methyl group and it is a bromine. Now I want to use C2H5OH and C2H5OH. Potassium tertiary butoxide and tertiary butyl alcohol. So in this case, follow Sedgwick product, so that the product you are going to get it like this. So this is what is called Sedgwick. You can say Sedgwick or Jadsev, doesn't make any difference. It is a bimolecular elimination reaction. What you said is correct. I know you are a very good student, but बीच बीच में इडली वड़ा पूरी डाल के आप divert करते रहते. But undoubtedly you are a very good student. And whenever you have a bulky base, the product you are going to get, it is going to be CH2. It is going to be Hoffman product. Hoffman product. Okay. Any doubt? Clear? Pakka. That's good. Now let us talk about dehydration. Dehydration means removal of water molecule. So it is an even mechanism. Let us say an alcohol, when it is treated with H2SO4 or H3PO4 or Al2O3 anhydrase भी इस्तेमाल कर सकते हैं. You are going to get a removal of water molecule. Okay, Smart Patel, Samarth Patel. I say Smart Patel because Samarth Patel is always smart. Okay, so you are going to get a major product and minor product. Bachcho, this is going to be the major product beta. So I will give you the mechanism. Look at this. OH, and if it is a protonated, okay, you are going to get OH is a poor leaving group, but protonated OH is a good leaving group. So ये लीव करके ये H2O निकलेगा आपका, ताकि कार्बोकैटायन फॉर्म होगा. Carbocation is going to be formed. Whenever carbocation is formed, it is going to give okay, and this can give you loss of proton, okay, so that you are going to get a double bond here. So further products is also formed. Muhammad Rahman, good morning. Okay, those students. So this is going to be the major product. And sometimes this carbocation, always you just see, whenever carbocation is formed during any chemical reaction in the organic chemistry, it has the ability to rearrange. So a less stable carbocation can be converted into more stable carbocation. So the order of stability of the carbocations, benzyl carbocation is more stable than allyl carbocation, is more stable than tertiary carbocation, more stable than secondary carbocation, is more stable than primary carbocation. जैसे carbocations है ना, vinyl carbocation और bicyclo bridge headed carbocation, जैसे carbocation कभी एग्जिस्ट नहीं करता बेटा. ओके, सो हैंडसम लग रहे हैं हम मास्टर जी, थैंक यू वेरी मच, गॉड ब्लेस यू. ओके, एंड which base is typically used for deep protonate terminal alkane? NaNH2. Okay beto, you have to use ammonia for that. Okay, moving ahead, dehalogenation. You can go ahead, dehalogenation. So उसमें मिलेगा आपको double bond, यहाँ पर रखना है. Okay, so dehalogenation. So there is no bond here. So whenever carbon vicinal dihalide, when it is heated with zinc dust, you are going to get alkene with zinc dihalide is formed. So this is one of the prominent reaction that we use in the alkene preparation. Okay, So you can also see chemical properties of alkene. Again, hydrogenation. I don't want to give a lengthy lecture. I don't want to give the lengthy lecture. So let us boost with a rapid revision. Hydrogenation. So we learned this whenever alkene is treated in the presence of hydrogen, platinum, palladium, whatever, you're going to get alkane. You're going to get an alkane. So this reaction is known as Sabatier-Sanderson reaction. Sabatier-Sanderson reaction, beta. Okay. And also you see halogenation. That is a super important reaction. Whenever non-polar solvent is taken as a CCl4, so carbon to carbon double bond, hydrogen is halogen is added, मान के चलो Br2 in the presence of CCl4, you are going to get two halogens on the opposite side. It is an anti-addition. So I want to say this gives the decolorization. Bromine है तो red है ना, there is a decolorization of the red color. So it is a test of the halogen. And according to one, what is the AAC1, AAC2, I don't understand. And whenever it is C double bond C bromine is added, you are going to get carbon to carbon bromine, 1,2-dibromine. Red is orange color is decolorized. So actually what happened, whenever carbon to carbon bond is there, so when bromine is being added, you're going to get a carbon and it is like this, okay, Br, and it is a positive. So it is a cyclobrominium ion, non-classical carbocation. Maybe Smart Patel or Samarth Patel, next 30 minutes the class will be completed. Okay, if you have any specific doubts, you please let me know. So when you add Br2, Br minus, it is going to attack on the reverse side, so that you are going to see Br and Br like this. So I want to say it is an anti-addition. It is anti-addition. So there is a trick. It is a stereospecific reaction. In this stereospecific reaction, there is a trick. So ATM and the CAR. What is this ATM and CAR? Anti-addition to trans alkene gives rise a meso product. So what is this? Anti-addition to trans. So this is a trans alkene. When you add Br2CCl4, you are going to get a meso product. So this is what is called as a meso product. CH3, H, H and CH3. And CAR, cis alkene on anti-addition gives rise a racemic product. CH3, C double bond C, CH3. You are going to get a racemic product. Racemic product is as a product है ना, it is going to give you Br and Br and Br and Br. So CH3, CH3. If it is a plus isomer, you are going to get, it is going to be corresponding minus isomer, both are mirror images. So mixture of enantiomers oppositely cancel their optical activity. That such mixtures are said to be racemic mixtures. So that is very, very important. This reaction, halogenation, is a stereospecific reaction. What is stereospecific reaction? जैसे reactions होगा, okay, a particular reactant, stereoisomeric reactant, should give its specific particular stereoisomeric product. Such reactions are called stereospecific reactions. Any doubt? KCP and TCP bhi hai na? KCP, TCP, you are going to see the addition of halogen halide to the conjugated dienes. There you can use the KCP and TCP. Kinetic controlled product and thermodynamic controlled product. So kinetic controlled product is the product that is formed by the first formed intermediate, and the product which determined by the chemical kinetics. So more stable carbocation is going to decide what product is going to be formed. Jitna jaldi de sakta hai. Okay, the one intermediate which is more stable is initially easily formed, so that decide the product, that is kinetic controlled product. But thermodynamic controlled product decide the natural product, natural tendency or natural stability of the product. So that is decided by the total delta G. Okay, so equilibrium constant and रिएक्शन रेट कांस्टेंट का हिसाब से जो प्रोडक्ट बना हो सकता है ये केसीपी काइनेटिक कंट्रोल्ड प्रोडक्ट, एंड डेल्टा जी जितना प्रोडक्ट का डेल्टा जी इज मैक्सिमम लोएस्ट नेगेटिव इज गोइंग टू बी थर्मोडायनामिकली मोर स्टेबल. सो द थर्मोडायनामिक स्टेबिलिटी ऑफ द प्रोडक्ट के हिसाब से प्रोडक्ट बना सकते हैं ना, दैट इज थर्मोडायनामिक कंट्रोल. Array, this is the organic chemistry. We are connected to the physical chemistry in various aspects. That's a wonderful question is asked by Anuj Gope Aj. And this is simply handled when 1,4-beta-1,3-diene is treated with HBr. So at low temperature, it is KCP, kinetic control product. At high temperature, it is going to be TCP at thermodynamic control product. Happy? Right? So what is the conformation? Which conformation of ethane and butane is most stable? Anti-conformation. Anti-conformation. Fully staggered anti-conformation is going to be more stable. Okay? That's good. Wonderful discussion with you guys. Any doubts? So moving ahead, polar solvent में अलग होते हैं. So halogen is going to be formed, and moving ahead, addition of HX. You have to follow Markovnikov rule. So reaction, so RCH11 CH2 when it is reacted with HX, you are going to get halogen is attached to the carbon with less number of hydrogen atoms. That is called Markovnikov rule. So what is Markovnikov rule? Beto, the negative part of the reagent should attack at this carbon of double bond which bears the less number of hydrogens. That is called Markovnikov rule. And one more important thing I want to say, Markovnikov rule can be used where there is no rearrangement. If rearrangement is there, directly you cannot use Markovnikov rule. Carbanion do not rearrange, carbocation rearrange better. Okay? So that's why the reactivity HI is more reactive than HBr is more reactive than HCl. Why HF नहीं लिखा? HF का reactions बिल्कुल अलग तरीका होगा. And you can say addition of HBr in the presence of peroxide. You are going to see the complete reverse of this. In the presence of peroxide, peroxide could be any organic peroxide. You know HBr peroxide effect is going to be applicable only for HBr, not for HCl or HI. This is what is called peroxide effect, anti-Markovnikov addition, or it is called Karash effect. It follows electrophilic addition reaction. And it follows free radical addition reaction. So the mechanism का नाम भी बहुत important है. ओमकार चावन, Birch reduction. This is what is called as Birch reduction. Shavan, fine. Omkar, fine. Happy? Enjoyed? Right. So this is very, very important. Look at this beta. HBr, if you use HBr peroxide, you are going to get Br over here. You are going to get a Br over here. Got it? That's good. Stay tuned. Please like the session. All of a sudden, Omkar has joined the class and asked a question. With no time gap, the question has been answered. So please enjoy this kind of lectures with a lot of fiery questions, and please like this session, share with your friends, subscribe to Infinity Learn NEET YouTube channel. Rosenmund reaction beta. What is Rosenmund reduction? RC double bond O acid chloride is reacted with PD BaSO4 in the presence of quinoline. So quinoline, you are going to get aldehyde is formed. So ऐसे reaction देखने का तरीका आता है. ये reduction है ना, ये क्लोरीन निकाल के हाइड्रोजन लगा दिया बस. Anush, fine, happy? Happy? Now moving ahead, addition of sulfuric acid in the carbocation formation. So chemical properties, alkene react with the called concentrated H2SO4, you are going to get alkyl hydrogen sulfate. Alkyl hydrogen sulfate. Addition of water, it is called hydration. You can add water in the presence of an acid, Markovnikov rule, carbocation is formed to get an alcohol. Dear beta, my dear children, alkene, you can say it is an alkene. So you are going to see alkene. This is your alkene. This alkene can be added with water by means of 3 different methods. I want to let you know these 3 methods. One is acid catalyzed hydration, and another one is hydroboration and oxidation, and PH3 THF and sodium hydroxide and hydrogen peroxide, and you can use mercuric acetate HgCH3 COO twice mercuric acetate and sodium borohydride and sodium hydroxide. So what happened? This is what is called as oxymercuration, demercuration, hydroboration, oxidation. Question PYQ na mains ko cold chem and for wala. We will discuss it. We will discuss it. Don't worry. No worries. Now you are going to see the products here. Rearrangement का हिसाब से alcohol बनेगा. Here there is no rearrangement, but you are going to get anti-Markovnikov addition. You are going to get Markovnikov addition and no rearrangement. I want to quickly write this. So carbocation, Markovnikov rule and a rearrangement. So these 3 things comes into the picture. Savena, hello. This is Avina Agarwal. This is a NEET chemistry class. Okay, Omkar sir, आज में हाइड्रोकार्बन डाला आपका इसका a part. This is a hydrocarbon. Alkene is one part. Okay, yeah. Please like the session. Those who entered the class right now. What do you want me to tell? आपने उसका ही part ले लिया. इसका ये सेशन का पहले alkene कर दिया. आज का सेशन में alkene कर रहा हूँ ना, alkene खत्म हो गई. Okay, and these 2 sessions can give a very good impact in this next week and the December 1st week. Total hydrocarbon live में 1 shot 3 घंटे का सेशन लेना चाहता हूँ. Okay, fine, happy, Omkar? That's good. So what is the remark for this? What is the remark for this? You are going to get an anti-Markovnikov addition. no rearrangement. Here strictly Markovnikov addition, but no rearrangement. Are you getting or not? Clear? This is a क्लास फॉर 11th स्टैंडर्ड एज वेल एज 12th स्टैंडर्ड और नीट ड्रॉपर्स के लिए भी ये आज हमारा सेशन फायदा होगा. ठीक है बेटा? राइट. सो मूविंग अहेड, ऑक्सीडेशन. दिस इज अ ग्रेड 11 का टॉपिक है, हाइड्रोकार्बन्स, बट ऑफिशियली ग्रेड 11 का टॉपिक है, बट 11th 12th एंड ड्रॉपर्स को भी इस्तेमाल कर सकता है. Avin Agarwal, hello beta, just focus on the academic strength here. So oxidation. So carbon to carbon double bond, if you use cold dilute alkaline KMnO4 is called as Bayer's reagent to gives rise vicinal diol, syn hydroxylation. You have, bacho, you have, this is an alkene. When you see this is your cold KMnO4, in the alkaline media, you are going to get a diol which is, syn diol. So what is the meaning of this syn diol? Addition of this hydroxyl group from the one side of the bond is called as a syn diol. Okay, this is what is called as a syn diol. Are you getting or not? Clear? And here I just want to discuss about the another reaction. If you use OSO4, osmium tetroxide and aqueous NaHSO3, you are going to get anti-addition. You are going to get anti-addition. Okay, so this is the product you are going to get it. This is the product you are going to get it. OH and OH. Okay, this is a very important reaction. Please like this session and share with your friends. Subscribe to Infinity Land NEET YouTube channel. So what is a facial isomer? कोऑर्डिनेशन कॉम्प्लेक्स उसमें आपको मिलेगा. कोऑर्डिनेशन कॉम्प्लेक्सेस में आपको मिलेगा. नाउ दिस इज अ खतरनाक टॉपिक, ओजोनोलिसिस. व्हाट इज द कलर चेंज ऑब्जर्व्ड इन द बेयर्स रिएजेंट? बेटा दिस इज अ पिंक इन कलर. बेटा potassium permanganate pink color is decolorized. Okay, sorry Betu, this is Bayer's reagent, is a test for alkene. Okay, moving ahead, ozonolysis. This is a very important, very important. Okay, so when carbon to carbon double bond is there, when it is treated with ozone and CCl4 and zinc, you can use ozone, CCl4, zinc and hydrolysis. Ozone, CCl4, dimethyl sulfide. In the examination, anything can happen, so that you are going to break this bond, make a oxygen, so reductive ozonolysis. No need. Simply ozonolysis are two types, reductive ozonolysis and oxidative ozonolysis. In the reductive ozonolysis, you are going to get C double bond O. And that C double bond O could be aldehyde or a ketone. If it is a oxidative ozonolysis, aldehyde जो फॉर्म हुआ ये आगे ऑक्सीडाइज करके आपको कार्बोक्सिलिक एसिड मिलेगा. कीटोन आगे नहीं ऑक्सीडाइज करना है बस. Arush, you have to use surface catalyzed mechanism for that. We already discussed it in the slide 1 or 2. You just go through that. Mechanism of the hydrogenation. Okay, beta. And I'll show that also. You can see this is the one. That is the mechanism. Already this is finished. Any doubt? You can see already this is finished. This is the mechanism. Okay, this is the mechanism. Got it? Any doubt? Fine. You can use platinum, palladium, rhodium, nickel. Okay, anything you can use it. And here one more important thing, after ozonolysis many things you have to do. Okay. Anyways, talking about the oxidation of alkenes. देखो बेटा, this is the properties of alkene. This is the last slide for the properties of alkene beta. What are the different workup condition for their products for the alkene? Okay, Betu, you can see here, this is your ozonolysis. In this ozonolysis you got it, the carbonyl. You have to isolate the carbonyl and you have to go for the routine test and to characterize the structure of these carbonyls to get actually what are the products. And based on this product, retrosynthetic analysis method इस्तेमाल करके आपका जो alkene क्या इसका नाम नीट एग्जामिनेशन में लिखने का बहुत इंपॉर्टेंट है. For that simple trick, take the oxygen and oxygen face to face, remove the double bond oxygens and make a double bond like this. You can say CH3. Okay, let it be. These are the various reagents. C double bond O. Okay, C CH3 and CH3 and O C CH3 and you can say CH2 and CH3. Now you simply remove this, and you're going to see that CH3, C double bond CH2 and CH3 and CH3 and CH3. This is the question you have to take from the product to give the reactant. Okay, very good. And you see, when the chemical properties in that, if this is the product, how do you get? So you are going to get various products. Okay, so how, what is the product you are going to get it on ozonolysis? It is a homework mentioned in the chart box how to get it actually. Okay, polymerization. Alkene undergo polymerization to give its corresponding polymeric structure like this, NCH2CH2. Ethene is going to give a polymerizer to give the polyethene. This polyethene is of two types: low density polyethylene, high density polyethylene, LDPE, HDPE. Okay, like that various questions you can get it. Okay, and polyvinyl chloride is also get. HP क्या होगा? You're going to get high temperature and high pressure. You can use benzoyl peroxide as a catalyst, Wilkinson catalyst, various catalysts you can get it. Okay, and here my dear students, overall Boston revision for the alkenes are completed, and we can have a couple of questions. Yes, look at this. So HCl is passed through propane in the presence of benzoyl peroxide. So CH3, CH double bond CH2. If you use HCl and peroxide, this is a trap. This is a trap. This peroxide effect doesn't work. Peroxide effect doesn't work for HCl. So that the product is going to be simply Markovnikov rule only. So I want to say isopropyl chloride, 2-chloropropane. My answer for this question is going to be 2. Are you getting or not? Clear? Are you getting or not? That's good. Fine. So butene can be obtained by the electrolysis. It is by Kolb's electrolysis. This Kolb's electrolysis we done in the alkane chapter. So 2,3-dimethyl butane dioic acid, Kolb's electrolysis. Are you getting or not? Yeah. Anyways, we are done for now. So we'll meet with more stuff in the next upcoming classes. Get ready, next week we are going to have one short total revision programs. So stay tuned and Thank you very much, my dear students. Thank you very much, and please like this session and share with your friends. Subscribe to Infinity Learn YouTube channel. Thank you. We'll meet with more stuff in the next class. Thank you very much. God bless you.